Hello, I am Mahaveer Rajpurohit. Now we will be discussing about the DHCP in Wireshark Lab. For this, there are some steps we need to follow to capture the packets. That is, first we need to type the command ifconfig release. Why this? To release the allocated IP address which have been allocated before to this device. I have to release that, and then I have to start capturing the packets using Wireshark. And I have to type in the command terminal ifconfig renew to obtain new IP address. And after it, I have to type again ifconfig renew to renew the IP address. And after it, I have to type ifconfig release to release the allocated IP address. And finally, I have to type ifconfig renew to allocate one IP address again. And then we will stop the capturing packets and we will analyze the packets. One thing to note is, for particularly this experiment, we have to type commands in Windows System 32. For that, I can open my file manager. In that, I have to go to my C storage. There I need to find this Windows. Then I need to locate System 32. This one here. And then here I can type cmd to open command terminal. So now first I need to type this ifconfig release to release the allocated IP address. Now how can I know I have allocated before one IP address? That one I can do by typing ifconfig/all. Now you can see here in this, I can see here there is a IP address that is allocated to me. Its subnet mask, and there is a lease which I have obtained, and there is a when the lease expires, and there is a default gateway which I have allocated to me. Now I will type ifconfig release. Now I can see here the IPv4 address have been released. Its default gateway, everything have been released. So now I will start the capturing packets. Here first I need to type ifconfig renew. So I can see here now that this IP address will be allocated to me. Its subnet mask and default gateway have been allocated to me here. Now again, according to the steps given in the PDF, I have to type ifconfig renew. So what I am checking here is, did I am getting the IP address another time? Yeah, I can check here. Another time I am getting the IP address here that I have renewed here. Now what I will do, I will release. Now I can check here again the IP address and default gateway and subnet mask are released. Now finally I will type again ifconfig renew to finally allocate one IP address. So finally there is an IP address located to me, its subnet mask and default gateway. Now I have to stop the capturing packets. So to observe the DHCP packets, I have to apply the filter boot P. So I can observe here my DHCP packets which I have captured. Now we need to understand DHCP DORA process. The DHCP DORA process, then DORA is D for discover, O offer, R request, and E acknowledgement. These these four components are what required to obtain a new IP address. I will explain you them using an analogy. So DHCP discover message. Now think of this as you, the house seeker, wandering around the neighborhood looking for houses that are available for rent. You don't have a specific address yet, so you broadcast your desire to rent a house to everyone in the neighborhood. Now then, DHCP offer message. Now imagine there are several homeowners, that is DHCP servers, in the neighborhood hear your broadcast and decide to offer you their houses. They provide you with the details about the houses they are willing to rent, including the address and how long you can rent it for. They send these offers directly to you since you are the one seeking a house. Then there is request R. After receiving the offers, you decide which house you want to rent. You send a request directly to the homeowner, that is DHCP server of the house you have chosen, indicating that you accept their offer and want to rent their house. Again, this message is broadcasted so that all the homeowners know your decision. And then finally there is acknowledgement. The homeowner, that is DHCP server, receives your request and acknowledges it. They send you a confirmation message letting you know that you can rent the house you requested. Now this message contains all the necessary details such as the address of the house you are renting, since you are the only one who has requested the house, right? They send this confirmation message directly to you. So in summary, what this DHCP process is like searching for and renting a house. You broadcast your desire to rent a house. Homeowners offers you their houses. You choose one and let the homeowner know. And finally, the homeowner confirms your request, provides you with all the details you need to rent the house. Throughout this process, communication happens between you and the DHCP client and homeowners, that is DHCP servers, ensuring that you get the house you need, that is an IP address, to connect the network. So you can similarly observe here that after capturing packets, what I have typed IP config renew, that I have obtained a new IP address, and I have told you just now for that the DORA process will happen. DORA, right? And then again what I have done, IP config renew I have done, means I am having before only the IP address, but I am requesting again, and it's for same that I have received the acknowledgement and I got another time IP address. Then what I have done, I have given the IP address release. Then I have observed corresponding DHCP release here, and finally I have done renew. So again there is a DORA process here, DORA. So in this fashion we are observe the DHCP packets here. Now let's solve some questions. Okay, so the first question is, are DHCP messages sent over UDP or TCP? For that, let's observe here, clicking DHCP message here, I can observe here that it is user datagram protocol. So they are sent over UDP. So the next question is, draw a timing diagram illustrating the sequence of first four packets, that is discover, request, acknowledgement, DHCP exchange between the client and server. Okay, for that I need to open Wireshark. Here I have to go to statistics, and here I have to go to flow diagram. So I am getting flow diagram for all the packets, but I want only for DHCP packets. Then I have to click here, limit to display filter. So these are the only DHCP packets. So first four, they are the discover, offer, request, and acknowledgement. These first four packets are for the DORA process. Next, it asking us for each packet indicating the source and destination ports, Are the ports numbers same as in the example given in lab assignment? So in this lab assignment, the port numbers are given here 67 and 68. So UDP uses two ports, that is 67, 68. 67, this port is used by DHCP servers to receive DHCP messages from clients. And port number 68, this port is used by DHCP clients to receive DHCP messages from servers. Let's check out here in Discover. I can check here for a Discover message. Source port number is 68, destination port number is 67. For offer, source port number is 67, destination port is 68. For request, source port is 68, destination port is 67. And for acknowledgement, source port is 67, destination port is 68. So the answer is yes. The port numbers are the same as in the example given in this lab assignment. Now the third question asks us, what is the link layer address of your host that we can observe in Ethernet? So here I check out in here Ethernet. This is our source link layer address, that is 90cc.df09.29.19, and here is the destination link layer address, that is FA.FD.1B.D9.95.85. So the fourth question is, what values in the DHCP discover message differentiate this message from the DHCP request message? So for this we need to refer to option 53. Let's track it. First I will select this discover here in this DHCP. I have to locate to option 53. That is, its DHCP message type is discover here, and for request, DHCP message type is request here. So this is DHCP message type. Differentiate this both. So what is the value of transaction ID in each of the first four packets? That is in DORA, discover, offer, request, acknowledgement, DHCP message. And what are the values of transaction ID in the second set? That is request, acknowledgement, set of DHCP message. And what is the purpose of this transaction ID field? Okay. So the first four packets, that is discover, offer, request, acknowledgement, having the same transaction ID, that is 0x1AAEA62D. This is the having first transaction ID. The second transaction ID is request and acknowledgement, and that is 0x88F4696A1. This is our second transaction ID. Now the transaction ID is used so that the DHCP server can differentiate between the client requests during the request process. So sixth one is, a host uses DHCP to obtain the IP address among the other things. That's right. But a host IP address is not confirmed until the end of 4 message exchange. Yeah, that is right. If the IP address is not set until the end of 4 messages exchange, then values are used in the IP datagrams in the 4 message exchange. Then what are those values? It is asking us. For each of the DHCP message, that is discover, offer, request, and acknowledgement, indicate the source and destination IP address. So you can observe here, for first discover, offer, request, acknowledgements, the source address here is 0.0.0 because it doesn't have initially the IP address, and its destination address is 255, 255, 255 and 255. That is, it is broadcasting to all the things. And for offer, it is 192.168.62.178. That is, this IP address have been offered to it. It again destination address is 255, 255, 255, which means it is doing broadcasting. And in the request, again the source address here is 000, means it doesn't have obtained the IP address. It have to be request to it. For that also it is doing the broadcasting. So its destination address is 255, 255, 255, 255, and finally it is getting the IP address. So its source address is 192.168.62.178, and it is again broadcasting. So 255, 255, 255, 255 destination address. 7. Now, seventh question is, what is the IP address of your DHCP server? So, DHCP server, we can check that in here DHCP acknowledgement that this address 192.168.62.178, it is the IP address of the DHCP server. So what IP address is a DHCP server offering to your host in the DHCP offer message? Indicate which DHCP message contains the offer DHCP address. For that, we have to open DHCP offer message. In that, we have to go to DHCP, and here we can see your client IP address, that is 192.168.62.134. This is been offered to us, and here we can check here DHCP message type offer. So the DHCP message with DHCP message type equal to DHCP offer contain the offer IP address. So in the example screenshot in this assignment, there is no relay agent between the host and DHCP server. What values in the trace indicate the absence of a relay agent? Is there a relay agent in an experiment? First of all, we need to find that. If so, what is the IP address of the agent? So we can check here. Relay agent IP address is 0.0.0.0. It means there is no relay agent. Explain the purpose of the router and subnet mask lines in the DHCP offer message. The router line indicates to the client what is its default gateway should be, and the subnet mask line tells the client which subnet mask it should use. In DHCP offer, you can observe here the router, and you can observe here the subnet mask. In the DHCP trace file noted in the footnote 2, the DHCP server offers a specific IP address to the client. See also in question 8, that is, what is the IP address DHCP offering to your host in the client's response to the first server offer message. Does the client accept this IP address? Where in the client's response is the client's requested address. So this is our first offer message, and in the request we can check out in the option 50. This is our requested IP address. It is 192.168.62.134, and successfully it have accepted this IP address. Explain the purpose of the lease time. Now the lease time is the amount of time the DHCP server assigns the IP address to the client. Now during the lease time, the DHCP server will not assign the IP given to the client to the another client unless it is released by the client. Once the lease time has expired, the IP address can be reused by the DHCP server to give to another client. And what is asking it is how long is the lease time in your experiment. So let's check out in Wireshark. I can check that in acknowledgement in DHCP. I can check out here lease time in options 51. The lease time in my experiment is 59 minutes 59 seconds. That varies depending upon the server. Now what is the purpose of DHCP release message? The client sends a DHCP release message to cancel its lease on the IP address given to it by the DHCP server. Now, does the DHCP server issue an acknowledgement of the receipt if the client's DHCP receipt of the client's DHCP request? That we can see here. After release, there is no acknowledgement. So the DHCP server does not send a message back to the client acknowledging the DHCP release message. But for acknowledgement, for a request, we can receive the acknowledgement. But for release, we doesn't receive any acknowledgement. What would happen if the client's DHCP release message is lost? If the DHCP release message from the client is lost, then the DHCP server would have to wait until the lease period is over for that IP address, until it could reuse it for another client. Now clear the boot P filter from your Wireshark window. Were any ARP packets sent or received during the DHCP packet exchanging period? If so, explain the purpose of those ARP packets. So let's remove the boot P filter. Now let's check out if there are any ARP packets. Yeah, we can see here. There are ARP packets here. There are ARP packets here. So what are the purpose? Before offering an IP address to a client, the DHCP server issues an ERP request for the offered IP to make sure the IP address is not already in use by another workstation. So that's it. We have solved all the questions here. Thank you so much.